Hi girls, here's the videos for 7C, polygons. A polygon, I think you know what it is already, but it's a two-dimensional shape, so it's flat on paper, and it has straight sides. So here's an example of one. This is a pentagon. It's got 5 straight sides. This happens to be a regular pentagon because the sides are the same length and the angles are the same size, and we call that regular. What is that again? Sides equal, angles equal. That's what regular means. This thing is weird. It's what's called a non-convex polygon. It has 4 sides, so it's a quadrilateral. It's a quadrilateral. It does have 4 sides, but it's got this angle that juts into the shape, and so it makes a big reflex angle inside the shape. This is a regular old triangle. It's scalene. All the sides are different, but it's still a polygon, a 3-sided polygon, a triangle. Non-examples are when I have something that's curved, so this oval or this weird kind of shape, space force shape. Those are not polygons. Alright, now the big deal about this chapter is finding the angle sum of each polygon. So the formula, which I think I talked about yesterday, it sometimes looks like this. I've written it that way, but it can also be written that way. 180 times n minus 2. Now n is the number of sides in the thing. Okay, so you're going to fill this chart in. I'm going to leave you to fill in all the blank spaces. I'll do this nonagon with you, even though it's there already. I'll show you on your calculator how to do that. Okay, I kind of realized I wasn't even on the screen, but let's do this nonagon here, and I want to try to get that 1260. So I use my formula, and this number of sides is 9. So I go 9 minus 2, and then I multiply by 180. So I'm just going to do that on my calculator. I'm going to do 7, because that's 9 minus 2, times 180, and I get 1260. So you can see how I get all these numbers. So fill these in. I think you know these two already. And then 7 and 11, and fill these in. All right, let's go on to the next thing. You can pause and do that. The next thing is about the different shapes. I'm going to go really fast, because you have these in year 7 and year 8 already. So a rectangle has 2 sets of parallel sides, usually marked with these little things, little arrows, and it has 2 sets of equal sides, and it has 4 right angles. And when I find the area of it, it's just length times width, or base times height, however you want to think. A parallelogram has 2 sets of parallel equal sides as well. It has a different area though. In a parallelogram, I need to draw a perpendicular height because it's kind of slanted. So I have this height, and then we call this the base, whatever the height is drawn to. And then the area of that is the same, base times height. A rhombus is a parallelogram that has equal sides. So it's like a square pushed over, but it's a parallelogram. I can use this formula for a rhombus, but it has its own unique formula where I can use these diagonals, diagonal meaning from one corner to the next. I'll call this diagonal number 1, and I'll call this one diagonal number 2. And I'm talking about the length of those diagonals. And if I multiply those together, let's see, times height, base times height, divided by 2. Okay, I think 1/2 of that will give me the area of a rhombus. Okay, and the last thing is a square. It also has all equal sides. It has 4 right angles. It has 2 parallel sides. You know, it's a really good one. A kite is this thing. We won't talk about the area of it right now, but it has equal sides here and equal sides here, And then these angles across this way are equal to each other. These are not equal to each other. And a trapezium, you'll remember, is this thing. It can look like that or whatever. It just has to have two pairs. These sides can't be parallel. Okay, let's find some angles here. This shape has 1, 2, 3, 4, 5, 6 sides, so it's a hexagon, and it's looking for this reflex angle right here. So I'm going to write all these down. I'm going to pause for a second. Okay, so I've added all these angles, 90 and 115 and 100 and 135 and 40 and A. So I've added all that up there, and I've gotten this. And I know that a hexagon angle sum is 6 minus 2 times 180, or 720. So I need to take 720 minus 480, and that should give me the value of A. So let's do that. 720 minus 480, 240. Now, does it make sense that this angle should be 240 degrees? Yes, it's a non-convex, so it's this big reflex angle inside. So I found that one. Let's just look at this one. This has 1, 2, 3, 4, 5, 6, 7, 8 sides. I'm just going to sneak in and look at my 8-sided figure. It was 1080 was the angle sum. When something's regular, I can just divide that by 8, and then I'll get the size of that angle there. So when I have a regular figure, so all the sides equal, I can just take 1080 and divide it by 8. I'll do that on here. 1080 divided by 8, 135. So I know B equals 135 degrees, and this exterior angle here makes a straight line with B. So A equals 180 minus 135, which equals 45 degrees. So not too bad. Okay, so at the bottom here, 7C, I just want you to do 5 to 7. So 5, 6, and 7, every second one, use a calculator. You do not have to draw the shape in your book.